Let's talk about biotechnology. Biotechnology is a science that is based on biology. Every life form is made of DNA, which are the building blocks of every life form. By modifying these building blocks through biotechnology, we can make a corn healthier. At the same time, resistant from bugs and pests. By manipulating these building blocks in another way, we can copy traits of an imported rice that has high threshold in water, then combine it with the local rice so that it can survive in the country. Biotechnology has a lot of advantages in many areas. For instance, in the medical field, we can select the vitamins and minerals we want a certain host plant to acquire. Imagine a life where most of the food you eat are filled with vitamins and minerals. These food can be given to less fortunate people where it can combat malnutrition. Awesome, isn't it? Through biotechnology, there can be healthier food to fight malnutrition in the country. There can be high-yielding crops. High-yielding crops make more income for farmers and helps the agriculture economy flourish. Biotechnology is everywhere. It helps us improve our lives and leads us to a healthier world.
Genetic engineering. In vitro DNA technology used to isolate genes from an organism, manipulate them in laboratory as per desire, and insert them into another cell system for specific genetic trait. The conceptual development of the principle of genetic engineering. The techniques of genetic engineering include creation of recombinant DNA, use of gene cloning and gene transfer, which helps to isolate and introduce only one or a set of desirable genes without introducing undesirable genes into the target organism. When a piece of DNA is introduced into alien organism, this piece of DNA would not be able to multiply itself in the progeny cells of the organism. But when it gets integrated into the genome of the recipient, it may multiply and be inherited along with the host DNA. This is because the alien piece of DNA has become the part of the chromosome which has the ability to replicate. The construction of an artificial recombinant DNA molecule emerged from the possibility of linking a gene encoding antibiotic resistance with the native plasmid of Salmonella typhimurium. Stanley Cohen and Herbert Boyer accomplished this in 1972 by isolating the antibiotic resistance gene by cutting out a piece of DNA from a plasmid which was responsible for conferring antibiotic resistance. The cutting of DNA at specific locations became possible with the discovery of molecular scissors, restriction enzymes. The cut piece of DNA was then linked with plasmid DNA. These plasmid DNA act as vectors to transfer the piece of DNA attached to it. Plasmid is used as vector to deliver an alien piece of DNA into the host organism. The linking of antibiotic resistance gene with the plasmid vector became possible with enzyme DNA ligase, which acts on cut DNA molecules and joins their ends. This makes a new combination of circular autonomously replicating DNA created in vitro and is known as recombinant DNA. When DNA is transferred into E. coli, it could replicate using the new host's DNA polymerase enzyme and make multiple copies. The ability to multiply copies of antibiotic resistance gene in E. coli was called cloning of antibiotic resistance gene in E. coli.
Singing an old song until it hurts just to